everybody. Hopefully you're joining us from, well, I'm certainly joining you from a wet and windy Aberdeenshire. So wherever you're joining from, hopefully it's slightly better weather, or at least if you're not, you are indoors in a nice warm place to join us for our first Tech 20 of the season and this year. So let's say welcome and thank you for joining us. David, before I get you to introduce yourself and explain what you're talking about, virtual and augmented reality. Interesting topic, something that's been around for a little while now in the gaming industry, but can we take it from the gaming and training industries and move it into on-site inspections from an offshore perspective, or even using this type of technology to replace maybe an inspector that's needing to mobilise during the COVID pandemic? So very interesting for us during this type of world we're now living in, which is why I'm quite interested in this. Jeff will also be joining us at the Q&A session as well, because Jeff is working on a project with us, looking at this type of technology with advisors. So again, has a bit of an insights and can maybe give us a little bit of a share and update of some of the work that's been done through there, because I think we had a trial offshore recently. So again, showing that this type of technology can work in the real world as well. So over to you, David, to introduce yourself and what are you talking about today?
Thank you. Hi, everybody. My name is David Sime. I'm involved in digital marketing and education, but I'm also involved in the application of extended reality, which is to say virtual reality and augmented reality, to engineering, construction, and primarily energy. One of the companies that I direct is called Riot Digital, which is realities into IoT, Internet of Things. So what we seek to do is combine virtual and augmented reality with sensor technology on site. But I've been doing this kind of things, communications technology and digital communications technology for the last 22 years. And as Rebecca said, virtual reality has been around for a long time. It hasn't really been fit for purpose, even in the gaming world, if I'm honest, until the last maybe five or 6 years. And it's only really been fit for purpose for engineering and so forth in the last 2 or 3. And the reasons for that are mainly to do with the advances in other technologies like battery technology, connectivity in particular, and the shrinking and optimization of computer chips. So now we can make things small enough, powerful enough, and well connected enough that you can wear them and you can connect anywhere in the world with low latency, low delay. And I'll take you through what I mean by that. Now, I've been trying to use virtual and augmented reality the last 2 or 3 years, even prior to the COVID pandemic, because we were using it to reduce the costs for the oil and gas industry and reduce the emissions for oil and gas and also for renewable energy, to get people to places to do their jobs without them having to actually physically go there. And that's what we're getting at today, is that we've got so used to traveling to places that now over the last year we've realized that for meetings and the kind of thing that we're doing right now, you can largely speaking get away with doing it remotely. But what if it's a practical task? What if it's something that really requires you to physically be there, that you really have to get hands-on with something, or you really have to be communicating with people as you're doing the job? You can't be sitting with a computer and Zoom on in that situation. You need something a bit better than that, and that's what we're going to go through today. So in terms of the problems that the oil and gas industry and the renewable energy industry, particularly offshore, was having with physical travel, the amount of time it was taking to send people for meetings and site inspections and this kind of thing was huge, and you were taking them away from the work. There was the travel time, there was the getting stuck in an oil platform because the weather's not good and the helicopter can't come to take you back. There's the potential shutdown time. If it takes a long time to get a specialist or an expert to a facility or one of your assets, whilst it's down, it stays down until that person can get there. So that's a real expense. There's the costs, and those costs aren't just in terms of how much does your flight cost you, or how much does the hotel or the subs and so forth, the individual costs. It's the reduction in productivity while that person's away from their desk, while they're away from where they normally would be working. That's costing you money. And then there's things like training and insurance. I mean, if you're sending somebody who's primarily, let's say, a financier, but you're wanting to get them involved in the actual process of maybe buying a new asset to go, and they need to actually see the asset or where it's going to be on site. That person has to have offshore training. They have to have all the insurance that's required, and that's very expensive, very time consuming. And therefore, there's a risk to, and the reason that there is all this training and all this insurance is the risk. There's risk to going onto zone 1 sites, there's risk to going offshore, there's risk to getting into a helicopter. So that's risk to personnel. But then if you get the wrong personnel in the wrong situation and they're not adequately trained, they don't spend every day on a zone 1 site and they do something wrong, that's your asset, could potentially be up in smoke. Or that's, you know, something which could be really badly damaged, which is going to cost you a fortune. And then finally, and this is something which is of particular interest to the renewable energy sector, if you're building a wind turbine and the purpose of this wind turbine is to reduce carbon emissions by a certain amount over the lifetime, but you're flying people in from all over the world to look at that asset, it defeats the purpose, doesn't it? Because the amount of jet fuel that they're using, the amount of carbon that they're emitting just to get there and back is huge. So travel emissions is a really big issue as well. So this is what we came up with a couple of years ago with Deuce and Babcock. So this is quite early stuff, but I'll show you what we managed.
When you have multiple diverse teams working on a project, enabling them to come together to share feedback and ideas can be crucial to the project's success. However, one of the biggest challenges and costs is in getting everyone to the same physical place for site visits, progress reports and inspections. In this example, high-resolution laser scans and photographs were taken of a Deuce and Babcock Visitor Centre. The data was then combined and processed to develop a fully explorable and interactive 3D environment. This digital space then became an online hub where multiple users can explore and talk to each other at the same time. Interactive elements such as video screens, presentations and 3D models can be placed in the environment, enabling users to collectively discuss them. Users can be transported to other locations where they can look around either a pre-recorded 360-degree video or photograph, or even view a live feed from a camera in a remote location. It is possible to view multiple locations or files all from within your bespoke virtual hub. Each session can be recorded, enabling users to replay it as part of a review process or training program. High-end computer hardware is not required, enabling those with modestly spec'd smartphones, tablets and laptops to join the conversations. Reduce or eliminate your need to organise complicated, time-consuming and potentially hazardous site visits with your own virtual hub. The potential time and cost savings are significant, with travel expenses, insurance and expensive safety training all being reduced. Get your teams talking and sharing more. Help them to collaborate, generate new ideas and find new solutions. Contact us today to learn how you can benefit from this technology in your industry.
So you can see that there's some advantages there. For instance, you can, or your stakeholders, no matter who they are or where they are, can view multiple assets. Let's say an offshore oil platform, they could view 3 of those in a day, 5 of those in a day, rather than having to spend days or weeks to get to just one. Travel costs, obviously, reduced or eliminated, depending on whether you can send everybody there virtually. Your training and insurance costs, reduced or eliminated, depending on whether you can send everybody there virtually. Your risks are eliminated or reduced. Your travel emissions are eliminated or reduced. So that doesn't cover everything, though, because this is just 360 visiting, right? So that's not the same as being there even virtually. So you need an idea of, you need a system that can allow people to actually do stuff in that space, not just look at it. So you need to have a physical process, you need to have a spatial process where things are actually contextually appropriate. It's not particularly good for installation apart from just viewing the area that you're going to install something in. Again, you need that spatial context. And you don't have full, in the example that I showed you, you don't have full stakeholder interaction because we don't have what we call avatars, virtual people talking to each other. So that was a couple of years ago. Here's one of the systems that we use now for design and development. This is from a company called Skyrail, and this was actually developed by Airbus for the aviation industry, but with our help, they transitioned into the oil and gas.
In this Skyrail VR video, an engineer at another location walks us through in virtual reality his plan to add a new section of pipework to an existing run on his offshore rig. Watching via our 2D screen, the engineer, using a VR headset and controllers, is represented by an avatar that we see on screen. We can jump between his direct view and our third-party view as he steps us through the process. Firstly, he removes the current section of pipework. Then, using standard parts from a custom library within Skyrail VR, he selects the sections he needs to build the new assembly. Next, we watch him snap those sections into place to build up the new run. At each step, he can select new sections from the custom library to quickly build up the new assembly. Using his VR controllers as virtual hands, he can easily place the sections into the correct location as he steps through the process. Having captured a video of the new process, he can easily distribute it to a wider team for discussion or jump into a live collaboration session within Skyrio VR to try out different ideas with engineers from multiple sites all joining in. Skyrio VR is able to track which sections he uses to start to build out the parts list for the work order. Having completed the assembly, he then uses the pipework design feature in Skyrio VR to draw a new cable run. Once finished, this cable run can be passed back into the CAD system as usable geometry to let the CAD team do a full workup of the end fittings. Finally, he steps back and takes a snapshot in VR to show the completed job ready for the work order.
So the advantages here are you can engage multiple stakeholders, whether that be your engineers, your on-site staff, your finance teams, your planning teams, your clients. And that means that also it doesn't matter where they're from or what technical background they're from or cultural or linguistic background they're from, it helps them to understand things because they can see it happening. The other thing is because it merges directly into your CAD system, you can import models from CAD so that if you've got them for your parts or your areas, then they can come straight into the virtual reality system. And then once you're finished building your array, it exports directly to CAD as well. So you can do the refinement process or bring it back into your existing workflows. Having looked at, it was BAM, and they were a helicopter manufacturer. They applied this principle to their design of helicopter manufacturing, and they reduced their design time by engaging all the stakeholders from 6 years to 6 months. Now that gives you an idea of the savings that you can have in the oil and gas industry. What do we still need though? What's still missing? Well, first of all, it's not live. Yeah, it's not actually happening in the place at the time. So it's not very useful for live maintenance. It's not engaging on-site workers in the actual venue live either, unless they happen to be part of the design process. And because it's in a model, a CAD model, it doesn't matter how accurate that is. It's not the real world, right? It's not raining. It's not got rust on it. It's not got the things which have changed since they made the model. So therefore, you really want full contextualization with really like right up to date models of the space.
Hello guys. Hello. Hello guys, it's Nabil and Fabrice from the Smart Room with Nobody. How can we help you?
So we had some intermittent vibrations last night reported by operations.
He said the vibration was reported mostly in the thrust bearing, correct?
Yes.
The deployment of rear-rack connecting helmet in combination with Microsoft Teams marks another step in Total's digital transformation. This is a real game changer.
Vibration issue could be linked to process issue. May you check it, please?
Adam, can you go closer to the manometer, please?
Put the HMT1Z1 on your head and you go hands-free. I can actually check vibration. I can check temperatures, with my hands. I can work. I can actually turn wrenches or open up a book. The potential is high.
Your final diagnostic, Fabrice and JC?
Yeah, to me, it's as I said, it looks okay, stable. So let's continue to monitor. And if the noise appears again, then call me right away.
Anna, you happy with that?
Yes, I agree. Anything else comes up, we'll reach back to you guys.
Today's deployment at Laporte Polymer Plant is just a start. We'll continue to deploy digital tools that connect frontline workers with subject matter experts wherever they are in the world.
So again, this reduces the requirement to actually fly out the specialists that you see there working back at HQ in different locations. It means that you can respond very, very quickly to risks or problems which are emerging, which means that it doesn't get to the stage where you actually have to shut down facilities. It means that your on-site staff are better utilised because they're actually learning through the process of interacting with these specialists on shore. But it's also better utilisation of your off-site specialists because they're not spending loads of time travelling to and from assets. They're there all the time to address these issues as they occur. However, you may have noticed the RealWear system is amazing. It was a step change, but things are developing even further. This one eye thing, that's an issue there because that can cause migraine and also it causes a blind spot, which is a safety hazard. It can't pick up thermography. You know that you heard that the worker was saying, I can feel whether the pipe is hot. Well, you don't really want to be feeling whether a pipe is hot if the pipe is like several hundred degrees. What you want is an inbuilt FLIR camera or a thermography camera. You want to make sure that anything, and this actually is Zone 1 compliant ATEX-wise, but you want to make sure that anything that you're bringing into that environment is Zone 1 compliant for high hydrocarbon or explosive environments. And you will have noticed from that video that the update, the frame rate was incredibly slow, very, very jerky. That wasn't to do with Zoom, that was actually live. That's an issue because that you can miss things. It can cause nausea if you're in a binocular headset, and it's just not ideal. And the delay, the latency, the delay between sending, okay, I should manage this. The delay between sending and receiving information from great distances, that right there has always been a problem. Fortunately, it's a problem that we can now address because we're working with the ESA and various others, the 5G centres and so forth, to establish or connect to low Earth orbit satellite networks. Now, anybody who's dealt with satellite connectivity before has most likely been dealing with high Earth or mid-Earth orbit satellites. There's a bit of a monopoly there, costs a fortune, the latency levels are really high. 750 milliseconds is nearly a second's latency each way. That causes massive delays. If you're wearing a VR headset and it's reliant on that, you're going to be sick everywhere. So you want to be careful with that. Low Earth orbit, much, much cheaper. A lot of competition already, and it's like sub 50 milliseconds latency. It's really, really fast. So that can be used to connect the shore to remote assets, whether they be offshore or whether they be in the middle of the desert or something like that. And the latencies are very, very low, and the connection speeds are very, very high. We're talking like practically optic fiber speeds. This gives you constant two-way communication, not just for virtual and extended reality, but for all of your sensor technology, faster and cheaper, and you can basically pay as you go with these systems. Point to point is obviously a lot more expensive to set up because you have to set up relays every I think it's about 7 miles. So it's much faster and cheaper to run than traditional satellite comms, as I mentioned, and 5G will communicate not just with other 5G equipment, but with 4G, 3G, 2G, and so forth. It works right back down the line, so it communicates with your legacy systems without having to update them. Very low delays, ideal for what we're talking about. So then you can end up, I'm just going to do this quickly, I'll skip to near the end, okay? But it means that things like this, where you're actually in a virtual reality headset actually becomes feasible. You can actually see things live as they are on the site. So you can actually be viewing what the worker on site is seeing at the same time live through a virtual reality headset.
Right, digital.
Also skip this one into 1 minute, I think. And this is from a company called Zinc360.
Like this one from Zinc360, which allows us to go into a specific refinery or plant which has been pre-captured and view it in more detail. Once inside this space, we can travel around and view again in 360, but this time looking at annotations of information which has been gathered and added to this space. Annotating objects and components with information which is useful to the users, and even live sensor feed information and data, which can highlight users when it moves out with normal parameters of pressure, temperature, vibration, or anything which has been set by the user. We can also use it to observe damage and to inform and instruct remote users on its repair. another of the many systems that we can move into.
Right, I'll just get through that. Now, this next system is another thing that you can do with this low latency. This is using HoloLens. Now, remember, HoloLens is not ATEX certified yet. There is something which actually arrived today in Aberdeen, which is ATEX certified and does everything that the HoloLens does and has a FLIR camera. So it's all quite exciting at the moment, but I'll play this for you. See.
In der Anlage für Zwischenprodukte findet eine echte Zukunftstechnologie bereits heute ihre Anwendung in der täglichen Arbeit, die HoloLens.
Die HoloLens setzen wir unter anderem im Betrieb direkt ein. Wir können projektierte Rohrleitungen, Apparate auf die HoloLens übertragen, ins Feld gehen, uns diesen Apparat direkt im Feld anschauen, obwohl es ihn noch nicht gibt, und können daraus schließen, ob es an der Stelle so in Ordnung ist oder ob wir noch an bestimmten Stellen im Projekt umarbeiten müssen. Also es ist jetzt nicht so, wie man es aus Videospielen kennt, dass man eine virtuelle Umgebung sieht. Ich sehe ganz normal wie durch eine Sonnenbrille, bloß die Teile, die ich noch sehen möchte, die ich drauf gespielt habe, die sehe ich noch dazu.
So I'm skipping on because I've got 16 seconds left. So the final thoughts are all of this technology can be used for combinations of facility management, asset maintenance, regulatory compliance, hazard management, worker safety, and also security and access control. We can show you how these can be streamed directly. Just email me at the email address below.
David, your time is up. We are very harsh, and then we just cut you off. That is the rules. So tough. But thank you for your presentation. For anybody that's got some questions, you can either use the Q&A function, so type in your question there and I'll read them out, and we'll get David and myself and Jeff maybe to give you hopefully an answer to your question, or if you prefer, you want to unmic yourself, so if you put your hand up in the raise hand function, I can bring you in. So before we start on some of the Q&A from the actual attendees, I'm going to ask one just to get sort of the conversation going. And it's around the fatigue side. I think there's been a lot of studies on, you know, our senses, especially from the Zoom and the Teams that we've been using daily. Does this also, this type of technology, bring in a different element of fatigue and some of the challenges we're seeing? Or do we think our brains will be able to generally start to adapt to this type of technology? Because I don't know, I just see a lot of people talking about this and some research being done. So have you been party to any of that discussions, or what's your thoughts on it?
Very good question, and it's an interesting result and a happy one for my industry, which is that I've been creating similar technology for education because I'm a lecturer and I've been working with Aberdeen University on this. We were concerned about the very same thing, Zoom fatigue for a lot of the lecturers who we involved, who we deliberately involved non-technical lecturers so that we can make sure that they can understand the system as well as anybody. And they said that they were having to break up their classes into no more than an hour at a time, usually 45 minutes at a time, with a break, and then no more than about maybe 3 hours of teaching time in a day, because otherwise people would get tired. Their uptake, the retention of information was very low, their uptake and their enthusiasm was very low, and their confidence at actually using the skills that they'd learned was very low. So then PricewaterhouseCoopers did an independent study on using virtual reality classrooms as an alternative. They discovered that the amount of time that somebody can spend in that space expands by at least 4 times. Their retention, 4 times higher. Their confidence in terms of being able to actually utilize the skill in the workplace, 4 times higher. Now, this is the same as or above the retention levels and engagement levels and fatigue levels of a normal physical classroom. I suspect it will, even if it is above, that's probably novelty value at the moment that's keeping people engaged. It'll probably normalize, but it looks like it's going to be around about the same as a normal working environment. So considerably better than this kind of environment.
So building on that question or that discussion point, and something that Keith raised in the Q&A is around that the sensory side as well, because obviously as human beings and the brain has a lot of different inputs, whether it's from smell to touch to almost taste. Is there a bit of a disadvantage, you know, if we are potentially replacing those type of sensory interactions, or can VR, AR give us that same complex piece that we use as part of our senses in assessing a situation?
You can, we're working with Tesla Suit, SenseLab and Haptics, and they all have physical feedback devices. So there's gloves that can give you feedback, where I remember at one point I was catching confetti out the air and I could feel the confetti between my fingertips. There was a tiny fox walking around my hand. I could feel its little paw pads. So you can use that, and not only does it give you the sensory feedback, it will give you the sense of actually, it'll give you resistance, so that if you hold on to something, your fingers will stop. So you feel like you're holding onto an object, whether it be soft or hard. And they can even actually apply things like temperature, heat and cold. So it's really, really powerful. But even when it's just gloves, your brain actually provides some of the rest of the information, because it was at one point I was bending a stick using the two gloves. Now, there was nothing giving me force feedback to my upper body, and yet I somehow felt like I was getting resistance from the stick. My brain was providing that. Even where that's not provided, the Tesla suit is a full body haptic system, and therefore it does everything that I just described, but all over your body, whilst at the same time measuring you for your ECG, EEG, and then using things like TENS actuators to give you sensation. So you can use that for training in work environments that can raise or lower your temperature as well. So you can get a sense of what it feels like to be in that environment. And if you cause an explosion, you feel the explosion. And trust me, you do, because I got nearly blown across the room virtually by my director, who was playing around with it. So yeah, the technology is there. You mentioned smell, very important. There are olfactory simulators which you can connect to the virtual reality headset. Smell is very important in memory, and you need to know things like the sound of escaping gas, the smells that are associated with potential explosion, and you can recreate these. It's been used in the military for a number of years now, with small devices, and you just attach them to the headset.
So it seems like technology has progressed quite significantly over the years, and especially from when some of the earlier stuff you did with Bruce and Babcock to where we're at now with Tesla suits, and you're all feeling and seeing and being almost immersed. But what else needs to be done? Luca raised this in the Q&A. What advances do we need? I think somebody else has also put into it. What's the step change needed to make this more commonplace? Because it's still a bit novel. There are some project activity ongoing and some trialing, but what is it? Is it the low latency? Is it the visors? Or is it just a combination of a lot of different other technologies that need to support this type of application?
You raised two very good points, the visors and the latency. Now, these are just on the point. I mean, my career changes every single day in terms of the development is so fast. It's just on the point of becoming fit for purpose, and it's already being used in education. We're using it in Oman and Qatar and Ghana in the oil and gas training industry at the moment. And these low Earth orbit 5G backhaul networks is giving us the reduction in latency, the speed of connectivity required to actually do what we need to do. And that's only just happening right now. I mean, literally the last satellites went up earlier this month, and now it's ready to go. The headsets, as I mentioned, you need headsets that are fast, able to compress data, ATEX Zone 1 certified, and one of the big six is certifying that right now in the North Sea. And ideally binocular, high frame update, and also SLAM. That means simultaneous location mapping. It knows where it is, it knows what it's looking at, and therefore it's spatially aware, so that when you are communicating backwards and forwards, like ship to shore, I guess you would call it, the people who are communicating with you from land know where you are, and your device knows what it's looking at, and therefore if there is something which is out of parameter, like heat going up, it can label the thing that you're looking at immediately and go, that thing is too hot, the pressure is too high, phone back, and then they can give you the advice that you need. So that was what was delaying us, and now is no longer delaying us. And so I think that for confidence, anybody who's wanting to use this in a real world situation wants to speak to their training people, because they're already using this and they can see how it works and they can see how well it works, and then make the decision on whether they want to apply it in the real world.
Okay, now I'm going to touch on Roger's sort of question as well, and maybe Jeff can give a bit of insights as well on the whole human pushback as well, in the sense that we've all been living like this for the last 12 months. And fun enough, we were just talking about this before we opened the session to live, to say at the start of lockdown, we were all like, yes, we're working from home, this is great, I sit in my jammies and I can work whenever I need to, and this is fantastic. 14 months or so on, where I'm going, I want to go back to the office, I want to see real people, and I want to feel and taste and be part of normal life again. So is this technology going to be pushed back by the human being side of it now, because we've realized that virtual is fine now and again, but maybe not every day?
Jeff, do you want to go on that one? I've got an anecdote, but I'm going to give you a chance to talk.
Thank you, David, and thank you for a brilliant presentation. Really enjoyed to see the work that you've been up to. I guess it kind of touches on the previous question as well, Rebecca. Firstly, one of the major challenges to overcome that we've been looking at, when you kind of put the actual development side of the technology to one side, we've been really looking quite heavily on the human adoption piece of using mixed reality technology, and what we need to overcome to do that. And we kind of found that it was twofold. The first bit was looking at trying to make the actual interface, the user interface, as easy and intuitive to use as possible. So someone can pick it up and use it. They don't need to have too much in the way of weeks and weeks of training just to be able to use the basic functionalities of what it is that they're looking at. And secondly, about, I guess, getting the right people with the on board in terms of mindset, having the right approach to this from the outset. Generally, people can be, we found that there's a mixture. There's people that are really open and wanting to embrace change. They want to see what the next best thing is and use it and get involved. And we found that other people are often quite reluctant and they need to be led along that journey a little bit more. So we found that by getting everyone understanding and able to use the kit to see exactly just what how much it can help their day-to-day working lives was a really big part in bringing them along on that journey. And by having it as a really easy and intuitive to use, we found that kind of went hand in hand to get over the kind of human side of the adoption challenge of what we need to do when we put everything to one side. What was the second part to your question again, Rebecca?
I can't remember now because we got distracted.
I just like to add, I would totally agree with what Jeff was saying there. In fact, we were actually pleasantly surprised. We're big on the whole people and processes technology adoption approach, because some of the people in our team have been doing this with different kinds of technology for the last 20 odd years, and they know it's not going to work if the person has a bad first experience or there's somebody in there in the structure who blocks it, who just doesn't want it to happen. So it's identifying the potential blockers and actually getting them on board. If you can get curmudgeonly 60-year-old Jim to go, this is amazing, then generally everybody else will follow. And we had an experience of that because we created a kind of an out-of-the-box VR solution. It's like 6 headsets, everything's loaded up, it's got its, Wi-Fi's all set up and everything. You just open the box, put the thing on and you're away. So we set up to say for training, and they had a guy who'd been on, they do like virtual reality simulations of lifeboat evacuations, and they had one guy who seemed to be quite resistant. He was a curmudgeonly Jim, and he tried on the headset, and I showed him around the virtual reality oil platform. He loved it. Absolutely loved it. He jumped right on board. He said, this is incredible. This is like playing a computer game with my son. I'm loving this. And then he went away and spoke to some other people, and then they all wanted to go. And they're thinking, well, if Jim likes it, then we like it. So there's elements to the implementation, but it is all about adoption. It is all about people. If you can convince the hardest to convince first, then they will frequently lead the way.
So Dean's raised an interesting point, and that kind of touches into this as well, because it's all about that sort of human reluctance potentially on the barriers to adoption. But Dean's saying there was Equinor were the first to get helideck certified using virtual inspection, and then they had an incident. So what happens when it goes wrong? Who's liable? Is it the AR companies or is it the individual operator? So yeah, if it goes wrong, and do you know of any other examples where it's not quite gone to plan, because this is quite an emerging type technology in our industry, but also other industries as well?
Usually there is the ability to prototype without putting people at risk, because you can create and refine the realism of the environment so that it gets better and better and better. For instance, we're in the process of getting a PITO certification for working at height training, and that has to be right, absolutely right. So what we do is we leverage decades of computer game technology, physics, fluid dynamics, you name it, so that we can recreate the effects of wind, we can recreate the effects of different weighting on you, we can recreate the effects of different equipment, and then we test and test and test with the likes of a PITO and with the likes of the trainers who train this physically. Say, is this realistic? Is this actually what it's like? And then we do a lot of testing in safer environments where we're recreating what we virtualized in a low and relatively safe physical one, and say, does it match? Does it match? Does it match? And once we've got it close enough, then we say, okay, it's ready for deployment. However, There is always the potential for things to go wrong, as there is with any training. And usually it's the training provider who is liable for this. Now, if we're working alongside the training provider, then there's shared liability, because we need to show that we have skin in the game. We need to show that we're not just going, yeah, here you go, your problem now. So it's something that we work with one, and we deliberately share liability for that reason, for their confidence. And then we deliberately also make sure that it's not we have sold you this thing, it's yours now. It's an absolutely ongoing process, continually, and it never ends. That they will always be working with us, we'll always be refining and taking feedback and making those improvements. So it's my hope that we will see fewer accidents, fewer problems with this kind of approach.
And then how does that tie into, the whole security side? Cyber security is obviously a big thing, and some of the challenging, as we go more and more digital. So again, are you seeing a lot of work in this space around the whole making sure these systems are as secure as we can make them? And given that sometimes that type of industry is usually a lot faster than sometimes the other part of the industry, but yeah. Well, I mean, I wouldn't want to say are they secure, because everybody's going to say of course they are, but yeah, are we confident they're secure?
Yes, my background originally was in marketing and digital marketing, and using like e-commerce and this kind of thing. So then we started dealing with banks, and then we started dealing with education for young children and vulnerable groups. So security and making sure that nobody who isn't meant to be getting in can get in was vitally important from the outset. So when you see like HTTPS, like secure socket layers on your website, imagine that times 20 and you've got all these layers of encryption. However, the safest is always on-prem, so not putting things into the cloud, and we always offer that as an option, or a combined option, where there's stuff that has to be secure but there's stuff that has to be streamed from a distance. We'll always try to get the balance of putting the secure things on-prem and putting the streaming ship to shore in the cloud, and then working out how to make that cloud-based streaming stuff as secure as possible. Fortunately, what I showed you with the low latency satellite networks, that's been built in from the outset, because they want to be using this for banking and for young education. So they've already worked on this very heavily in terms of encryption as well.
Perfect. And maybe one for you, Jeff, as well, because you've obviously recently been down working with the Visor guys and been offshore. Training. How much training is needed for the actual individuals to start using this type of technology? It seems quite straightforward enough, but is it?
I think it's a good question, and David touched on it just slightly there. Is I guess they're just getting to the point now where the devices, where the systems are at the point where they're actually being really useful and they can be meaningful to for use in industry and in real life effectively. So what I think personally it looks like just now, you're going to need specialist companies to help with the setup or with the development of certain bits of software and kit, but as long as they are being, which to all accounts they very much are, developed in a way that actually they can be used by I guess the end user, who in a way that it's intuitive and easy to use. It's actually just like, instead of doing their job, so an example would be, we saw the video that David showed where they were building the different pipe sections together. You still need someone with the piping background or the expertise to know which bits of pipe to put together, what the pressure should be, what materials should be used in that. You still need that expertise, and this isn't ever going to take over that role. You still need someone to do that, but they currently use a system to do that is the traditional means of doing it. So hopefully the systems within this virtual or mixed reality world mean that they can just take that skill set and apply it and use the intuitive nature in the way that it's been set up as a user interface to develop and create, or to keep using that existing skill set to build the pipework in a different system. So I think that there's a new skill set needed in order to make these systems work. So rather, should I say new to our industry, but not in terms of actually what you're doing, the work, what you need to use these systems for. Those skill sets we very much have. They are the traditional skill sets that we already and engineering backgrounds that we already have and have well established in our industry. You agree with that, David?
Absolutely. I mean, that's kind of my job and my team's job, is that we form the bridge between the industry, their needs, and the people involved. And the specialists have built the systems to find the right systems, the right combination usually of systems, to solve the problem, and then work on the implementation, work on the buy-in, and then work on the constant refinement and the constant changing. What we seek to do is to create effectively sandboxes or work areas that allow people to do a lot of things. People who are already specialists in what they do, like you mentioned, Jeff, like a pipe fitting specialist. You need that person, but you don't want to prescribe, right, this can only do. You want an environment that works like the real world, but better, where they can do what they do, but better, with fewer restrictions. And that way we learn from them as well, and we don't limit their.
Yeah, absolutely. And I think that's actually another question that you mentioned about what happened at the time that something went wrong when someone was using one of these. These systems are not here to replace the trades and the work that already happens in the different environments that we work in. And actually, I think that you can develop the systems in a way that allow them to help and benefit people in their day job, but still allow the check-in points for the skills and expertise, or people with skills and experience to check in and actually kind of put their physical mark on it to say, okay, even though the mixed reality system has helped me up to this point, I'm still going to go in and check and say, yeah, that this is still safe, that what's been done has been done correctly and as it needs to be, and we can now move on to the next stage. So it's going to be, I guess, a mixture of the both, working hand in hand, using the skill sets that we still have.
So we're coming to our end of the session, and obviously we get cut off at 20 minutes. There is an opportunity to carry on the conversation. I am liking the new timer system. Our old Tech20s, which were virtual, didn't have this function. So this is quite a good one, because it does make sure we keep to time. So as a closing sort of remark, and before we go to the networking session that people are welcome to join us on, certainly to me, I think this technology has a little way to go yet before we're going to see it every single day in our normal environments. A few different challenges from the human side to the technology side to some of the other sort of more operational and hands-on piece. So I think it's an exciting place to watch, but I think certainly, I don't know if my own personal opinion, I don't think we've quite made the leap from the gaming virtual world into day-to-day operations with this type of tech, but I think it does still need a little bit more work to really be commonplace. But that's hopefully why we're all as an industry now working with the different solution providers to bring this hopefully to a bit more of a day-to-day piece. So it'll be an interesting piece to watch over the next few months and years to come. Thank you for obviously attending. And again, if you do want to know more about this technology, reach out to us, either straight to David or to us at OGTC, because this is something that we're quite interested and are trying to work with the industry to support this type of technology in its deployment and overcome some of the barriers to that deployment. So